Okay, this is Lab 50, and so we're going to get going on it. Let's get the paper view going, and let's see what we got here for Lab 50. Oh, that's Lab 51. We're only doing Lab 50. Okay, so Lab 50, Austin is working on the perfect Shirley Temple. He has made a batch with 10% grenadine that is too weak and made a batch of 60% grenadine that is too strong. He is now out of ingredients and would like to mix the too weak batch with the too strong batch to create 50 liters of 30% grenadine. Shirley Temple. How many liters of 10% solution and 60% solution should be mixed? Set up a system of equations and solve for full credit. Okay, so that's what we've got to do. My chemistry teacher at Foothill High School, Mr. Com, I didn't know could not solve these in my algebra class. And so he was like, let me show you how. And he set them up with beakers. And so that's what I do still today. You can use the box method that the book uses if you like, full credit either way. But in the beaker method, you draw these lovely beakers. A beaker is something that you would mix chemicals in a chemistry class. So you can draw anything you want. It doesn't really matter. So this is the mixture. And what we want of the mixture, and this is the weak solution, we're going to call it weak. Is it 2 E's or an A? It's an A, right? 2 weeks is the days of the week. Anyway, and the strong solution. And so Mr. Com said to put the percentages on the outside of the beaker and how the volume, how much there is on the inside of the beaker. So that's what I still do. And so, so let's read it. He's made a batch that's 10% grenadine. That's too weak. So 10% right here underneath the weak. And I can write the percent or not. It doesn't matter. And in this particular type of problem, it does not matter. And the weak and made a batch that's 60% is too strong. This is the classic, it's not Little Red Riding Hood. That's too weak and too strong. It's the one with the bears. Who is the person with the bears? Oh my gosh, the 3 bears. I cannot think of the person with the 3 bears. I hope you guys think of it. Send me an email and tell me who. 30%, right, is the mixture. And we want 50%, 50 liters of the 30%. So 50 liters right in here. And the weak and the strong are what is unknown. That's what I'm trying to find. So I have this one equation that's built totally on volume. And that's the weak plus the strong equals 50. Goldilocks. That's who it is. And then because 10, when the percentage means 1 over 100. So there's 1 over 100 here, here, and here. So if I multiplied everything through by 100, it would get rid of all those percentage signs. So you definitely could keep them there. Then the first step would be to multiply by 100. And I'm just kind of too lazy to do that. Quack, quack, quack goes my phone. I'll turn it off so it stops its quacking. And so that's one of my students. Okay, so you multiply, remember, the inside and the outside of the beaker together. And you can, since I'm multiplying by 100, all of them, you can ignore the percentage sign. So this is 10W plus 60S equals 30 times 50, which is 1500. And that's the part that people normally forget to do, is they forget to multiply right there, the 30% times the 50. When you do that, you're saying 30% of 50 liters is pure grenadine. And of course, I've lost that when I multiplied by 100. I've lost what was going on there. But that's what's happening is we're just looking at how much pure grenadine there was in the mixture. And I know what you're saying. You're saying, who needs 50 liters of Shirley Temples? And Austin, my nephew, was the bartender at the Crystal Palace. And so obviously He needs that, particularly when they have kid night at the Crystal Palace, right? For the line dancing. Okay, so what you need to do is, you ever been there on kid night? It is fun. And so you need to multiply through by 10 so that you can drop out the W's. So I'm going to multiply here by 10, negative 10. And I'm out of room, so I'm going to write it right here. So negative 10W minus 10S equals negative 500. And then what I'm going to do to this equation is I'm going to do nothing, which of course reminds me of a Louis Armstrong song. You got to look it up. Do nothing until you hear from me is what it is, and you got to look it up. So 10W plus 60S equals 1500. And here we're going to get 50S. I'd play it for you, but then I would get copyright struck or whatever have you. I've gotten the email before when I played a Pat Benatar song about the chain rule for my calculus class. Anyway, whatever. They don't allow you to have any fun on YouTube. And so dividing by 50, here I'm going to get S equals, and then 1,000 divided by 50, I believe, is 20. So of the strong solution, I have 20 liters. And if I had 50 liters of Shirley Temple, and 20% was from the strong, 20 liters was from the strong solution, then that would mean that 30 liters to make 50, right? 30 and 20 are 50, would be from the weak solution. So that's kind of the story there. So we did a lovely job on that. Then we have number 2 on Lab 50. And let's see, solve each equation. Solve each of the following inequalities. Write your answer in interval notation. Obviously, that was written for the homework where you had a whole bunch of them to do. And this is just one problem here. I noticed that it's a fraction inequality, which is called a rational inequality. So this thing has a name. All equations have a name, and it's a good idea to know what they are, because if you can identify what they are, then you know the steps to solving them. Oh, there's those scissors I was trying to find. Gosh darn it, you hide stuff from yourself in your house, and then it's like, I wonder what they were doing right there. That's a crazy place for them. But anyway, that's where they were, and I'd been looking for them for days. And so what you do, number 1, is you identify where it's undefined. Now, where it's undefined is where the denominator is equal to 0, because that's not allowed. And so that's at x plus 3 times x minus 4. That's when that denominator is equal to 0. And that's equal to 0 when x is negative 3 and when x is 4. Now, these are not solutions to this problem right here. These things are actually not solutions. And they're things that I want to put on the number line, because things are going to change at that. As I get closer and closer to those non-solutions, things are going to change. And so these are always open. And then number 2, you want to find where it's called the boundary. And I know I told you guys in class about looking at the fences with a whiskey bottle on each fence, empty whiskey bottle on each fence post. And that always makes me think of the boundary there, coming home from San Luis Obispo. Kind of funny story. But the good news is when you have 0, that boundary is just the numerator, because you have this x minus 2 divided by whatever you have down here, it doesn't even matter, equals 0. And then when you multiply by the denominator to clear the fraction, so you multiply by the denominator to clear the fraction, it was x plus 3, x minus 4. Here I had x plus 3, x minus 4, it doesn't matter, right? And I'm going to multiply here by it as well, x plus 3, x minus 4. And they cancel here. Over there they get wiped out with a 0. Thank goodness it was a 0, because if it was a 1, you would know that you had woke up and were in Math 1, because it's a little bit more difficult. There were a couple of ones in our textbook, and maybe even a one on the XYZ homework. But so far, I've always given you 0 over there just to be kind and friendly, because it wipes out. And then that gives me X's too. Now, this could be an open place or a closed place, and it depends on this right here. And because this is greater than or less than, it's open. Had it been or equal to, it would have been closed. So then the third step is to put everything on the number line. So here I am with my number line. That's the third step, is number line, and test points. And so we're going to put on our number line -3. That's the smallest number we got. The next smallest number we have is 2. I'm going to put that on here. If you were a real, person that was really wanting to be careful, then you could put in here, here's 2, open circle at 3, -3, open circle at 2, 3, and 4. And you could put it all in here, all accurate on your number line, but that doesn't really actually matter that much, although, I know how it is. And so now I want to do a test point. And Dave Meyer says that until you're in Math 1 and you understand the theorem about when it's going to alternate, true, false, and when you don't know it's going to alternate, you should test every region. And I even tell my Calculus 3 students to test every region. But I'm going to tell you right now that I won't give you one that won't alternate. And so if you want to be lazy and test just one region, you can. I'm going to test x equals, so this is my test point, x equals -4. I could also test x equals 0. X equals 0 would actually be easier on my arithmetic, and maybe I'll just do that. I talked myself into it. So if I test x equals 0, I get 0 minus 2. I'm back in the original. Divided by 0 plus 3 and 0 minus 4. And I want to know, is that less than 0? So in the numerator, I get -2. And in the denominator, you can see I can do the arithmetic in my head when I use 0. I get -12. And a negative divided by a negative is a positive. This is 1/6 is less than 0, and that's false. It's not. A positive is not less than 0. So that means right here where 0 is, this region right here that we have, from -3 to 2 is false. And remember I told you that it's going to alternate. Now, when does it alternate? Well, you're going to learn a theorem about when it alternates in Math 1. And so in college algebra, where we haven't known that theorem, they say test every region so that you can verify that it's going to alternate. And then I said to you, shh, don't tell anyone. Don't tell anyone. It'll always alternate on the problems I give you. And so if this is false, this is true, and this is false after 4. What is the divider? Are the points that we found, right? These open circles that we have here are the divider. So this is false, so this one over here is true. And you shade the true regions. Shade the true regions. False regions are not the answer. The fourth step is to write your answer in interval notation. So that's the fourth step, and I'm going to put it here on the solution line because I'm feeling kind of lazy. So I'm going to start here at -infinity, and my solutions end at -3. So -infinity to -3. Union 2 to 4. Done. Hot diggity dog. That's what I'm saying. Anyway, so that's our story there. Those are the solutions. I know I'm all about checking my answer, and you're like, every time you have an inequality, you don't check your answer. Well, you could check your answer. This is right. My answer is number 4. With doing a few test points in every region and make sure that all the solutions are in this interval, these 2 intervals that I have here. And definitely could. So you could say, well, is x is -4 a solution? Is x -5 a solution? And you could test them if you like. You'd have to test a bunch of them, but you could. More power to you, I'd say. So I see this absolute value, and I'm supposed to solve it. And I kind of have this story on absolute value already in my head, and it's absolute value inequality right here. And it'll be all I can do not to get another piece of paper here. But your absolute value has to be all by itself on one side of the equation, so I'm going to take away 4. So the absolute value, 2a plus 1, is greater than or equal to 3. Then I have choices. There's the boundary method, and we use the boundary method right over here. That's the method we use, where you find the boundary happens at equals, and you do test points to figure out where the inequality is true. So we could use the boundary method, and that's what I showed you in class. Now, your book doesn't use the boundary method. They use the memory method. That's what I call it anyway. And they say that if you have a greater than, and so they say this, if the absolute value of A, whatever stuff you have in here, is greater than some positive number, and then they say then A is less than negative of that positive number. This is just memorized. Or A is greater than that positive number. And then you solve that. This is the memory method, if you will. And of course, you would have to have a memory method for if you have greater than, and a different memory method if you have less than. So if you had less than, if A was less than the absolute less than this positive number, then negative A is between, not negative A, that's negative positive number there. My memory verse, greater than A is in the center, and then that positive number up here. And so you have these different if-thens depending on if you have greater than or if you have less than. And if you didn't have a note sheet, right, because now I have 2 of them, and guess how many there are? Well, how many symbols are there here? There's the greater than symbol, there's the greater than or equal to symbol, there's the less than symbol, and the less than or equal to symbol. These are similar to each other, so you could have that. But then what else are the other opportunities? Well, there's positive number, and there's negative number, and there's 0. And so if you started really listing out all of the possibilities, there would be a lot of things to have, and it would be like, oh my gosh, that's a lot. And so that is your book does this. And there's nothing wrong with it. I rotate from semester to semester. I usually follow the book. This semester, however, I showed you guys the boundary method, and because it's less things to memorize. And so if you wanted to use the memory verse, well, this is not this. They don't match one another, so you wouldn't use this one. That wouldn't be the one you use. You would whip this one out, and this is the one that you would use because I have a positive number. The positive number is 3. If I had a negative number, then I would need a different memory verse, and I would have to have a different one on my card. I actually wrote them all on the board, and I'm not going to take the time to write them all here. But if you came to my office hours, I'd write them all out for you. But I'll show you the boundary method, because the good news about the boundary method is there's less memory. So on the boundary method, you say the boundary happens at equals. So 2a plus 1, absolute value equals 3. Then I go into my memory verse on absolute value. So if I have the absolute value of some stuff, we'll call it A, equals a positive number, right? Then that means, this is the if, then that means that A equals negative of that positive number. So I'm going to have to solve that. Positive. What? Number. Or A equals that positive number. There's one for if the absolute value of A equals a negative number. And guess what? It's different. Do you guys remember what it is for a negative number? Negative? What? Negative number. Then Yeah, no solution. So that would mean no boundary point. And what if it equals 0? And so you can go look that up. But if it equals 0, then there's just not two cases, but there's just one case. And so that's kind of the story there. And so here I am. I have positive number here. So I'm having 2a plus 1 equals negative of that positive number. So negative 3. Or, and then the other solution for the boundary, a plus 1 equals 3. And then I just have to solve those. Now, they're not going to be my solution when I solve those. I'm going to have to still go to my number line, right? So when I solve those, I'm going to take away 1 here. And I'm going to get 2a equals negative 4. And I'm going to divide by 2. And I'm going to get a equals negative 2. And I'm trying not to get into my solution line there. And take away 1. So 2a equals 2. And a equals 1 when I solve that, right? So those are going on second step. And a lot of people were showing me, they were solving it and they were doing this first and they weren't doing the second step. And so I told them, well, you're going to have to use this method if you only want to do one step, because this method is one step, right? But if you do the boundary method, you do have to go put this stuff on your number line. So negative 2 goes on my number line and 1 goes on my number line. Because this is or equal to, they're solid circles. And then I got to do a test point. I like to test x equals 0. And, but it's a this time. A equals 0. So I get the absolute value of 2 times 0 plus 1. So that's the absolute value there, absolute value, plus 4. I'm back in the original. Always back in the original when you test, right? 4 is greater than 7. And I want to see if this is true. So this is 1, and the absolute value of 1 is 1. So 1 plus 4, you can put that in your calculator, is greater than 7. And the answer is no, it's not. 5 is not greater than 7. If it is, bring me $5 to my office and I'll give you 7. No, I will not. Let's see. You bring me 7 and I'll give you 5. That's how it needs to be. Okay, so this is not true. So that means where a is 0 is not a solution. So negative and a positive, 0 is in between. So this is a false in between. Not true in between. So that must mean that true is over here because it alternates, and true is over here. So our answer, that's the last step, goes from negative infinity to negative 2. And it includes, so bracket, union, it includes 1, so bracket, and then to infinity. And so remember that the brackets go with solid circle, and everything else is infinities are always parentheses. Open circles are always parentheses. I'm going to take off my boots because I've had enough of wearing these boots. I don't know if I've had enough of wearing the sweatshirt yet. But probably pretty soon I'll have had enough of that. Okay, let's see here. Graph the following. Number 4 out of 9. Graph the following. State the domain and the range and whether it's a function. So I notice that it's x to the first, and over here is y to the second. And so we have something that is x to the first and y to the second, right? That's what we have. And we're looking at the lead terms. I'm not looking at any of the numbers or anything like that. So we know it's a parabola. How do you spell parabola? P-A-R-A-B, parabola. Why, I normally can spell it. Oh my gosh, I'm gonna have to Google it because I can't stand not being able to spell something like that. That's crazy. I know I'm a very poor speller. I know that I was when I typed it in, though, I typed it in totally correctly. I knew I'm a very poor speller when one time I asked a first grader how to spell something and I was an adult. And so it's a parabola. And so anytime that you have one variable linear and the other variable quadratic, you get a parabola. So it's a parabola. The important features on a parabola are the vertex. So when I find it, I'm going to put it right there. How you find the vertex, if it's in vertex form, which this one is in vertex form, is you let the base, so y minus 3 is the base, be 0. So the value that would make this base be 0 is when y is 3. And so when y equals 3, that's going to be the vertex of the parabola. So when we put in y is 3, we get x equals, and then it's going to be 3 minus 3, because we wanted that to be 0, plus 1. So x is 1. So that is our vertex of our parabola, because this parabola is in vertex form. 1, 3. And then I want to pick, so this is kind of what I have. I have x, y here, and my vertex, I kind of think of it as being the center, and I want to pick things that kind of walk out from that vertex. Now everything's in terms of y because the equations solve for x, which normally they're solved for y, but I want to pick, like one higher and one less. So this would be like one less would be 2, and one less again would be 1, and one higher would be 4, and one higher would be 5, and then I kind of will have all this symmetry. So when I put in 2, right in here 2, I get 2 take away 3, which is negative 1, and then I square it, and I get 1, and I add 1, and I get 2. And you can put it in your calculator. Go ahead, I dare you. And I should be checking my answers here. I think I've had a long enough day that my answers should be verified at all times. So 1, 2, and 3. Oh, so far so good. Comparing to the answers that Lucas got, I think I'm doing pretty good. So here I put in 4 minus 3, I get 1. 1 squared is 1, plus 1 is 2. And we knew that there was going to be that symmetry. 2, 2, notice it. And then 1 and 5 are going to be the same. So I'm going to put in 1. When I take away 3, I get negative 2. When I square it, I get 4. And I add 1, I get 5. And here I'm going to get 5 as well. 5 minus 3 is 2. 2 squared is 4. Plus 1 is 5. So yeah, and you can use a calculator. It would be lovely. And so over 1 up 3, 1, 2, 3. Over 2 up 2. Over 2 up 2. Over 5. 1, 2, 3, 4, 5. Up 1. What order did I go in? Willy-nilly. I was just going in willy-nilly order. So over 2 up 4. Over 5 up 5. So 1, 2, 3, 4, 5. And you can see the parabola going right here. The domain of that parabola is, if I was thinking, how far to the left do I go? Well, I only go here to 1. And so that starts here at 1. And then from 1, how far to the right do I go? Well, I go all the way to infinity. How low do I go? That's the range. Well, I would slowly, I know it goes down and down and down, but slowly. I go all the way to negative infinity. And how high do I go? Well, really slowly to go up to negative infinity, but I do go to negative infinity. And is it a function? Well, any vertical line I draw would hit my parabola twice, so no, it's not a function. So nope, not a function. So we did a lovely job on that. We're on that was number 4. Now we're on number 5. Hot diggity dog, we're moving along. And of 9, of reviewing the whole entire semester. So I look at this and I notice that I have y to the first and x to the second. And when you have one linear and one quadratic, it's a parabola. So 2 parabolas right next to each other. What's the odds of that? Parabola, and I'm not spelling parabola right, but I spelled it right there. What the heck? This parabola is not in vertex form. And so since it's not in vertex form, it's actually in standard form. So to find the vertex, the x coordinate of the vertex, because we have x being quadratic, is given by negative b over 2a. And in this case, RB is 12. So negative of 12 over 2 times 3. My parenthesis made my negative look silly. So here I've drawn it better. So that's negative 12 over 6, which is negative 2. Now I want to find the y-coordinate of the vertex. The vertex is the most important feature on a parabola. People have been telling me it opens upward or it opens downward and other points on it. And I'm like, cool. That's cool. You can tell me those. Those are important features as well. But the most important feature is the vertex. And so if you just told me the vertex on this line, that would be fabulous. I'm just trying to get you to tell me some points that after you decided it's a parabola, tell me something else about it. So here I am, y vertex equals 3 times squared plus 12 times plus 5. And what is it? Well, it's negative 2. And then when you do the math there with a calculator, you can do it without a calculator if you want. 3 times negative 2. You do you. Plus 12 times negative 2. I hope it's not too big. I hope it doesn't get off my paper. Hope I don't have to rescale. These are all the things I'm thinking. I get negative 7. So the vertex is negative 2, negative 7. And so it's right here. Over 2, down 7. And so if this parabola is opening upward, then it's not going to go any lower than that. And so that would be great. If it's opening downward, then I probably should rescale because everything's going to be really off of the grid. How do I know that it's opening upward? Is because A equals 3, which is positive. And so that means that it has a smiley face is what it looks like. So here's the vertex right there, and I'm going to get a smiley face. So when I pick a few points, positive, the vertex is here in the middle. This time it's in terms of x, right? So in terms of x. And so if I go bigger, right, from negative 2, that's negative 1. If I go 1 bigger, that's 0. If I go smaller, that's negative 3, and that's negative 4. And so now I'm going to pluck all these points through that equation. And luckily, I already have it in my calculator. And so all I have to do is do a little editing. So that 2 is going to turn into a negative 4 equals 5. So this is 5. That 4 is going to turn into a negative 3. And that gives me negative 4. That negative 2 I already did was negative 7. And negative 1 is my last one that I'll have to put in my calculator because I'll be able to do 0 in my head. But you could do 0 on your calculator as well. Do them all on your calculator. Do them twice. What the heck? And when I put in 0, right, and I do the arithmetic 0, 0, that's 5. And I knew that there was going to be that symmetry. Do you guys notice? So negative 4, negative 7, negative 4, negative 4, 5, 5. Okay, hot diggity dog. So I'm going to plot these points, and they're going to make a parabola that looks like that. And so I've already plotted negative 2, 7. I'm going to plot negative 3, negative 3, negative 4, 1, 2, 3, 4. I'm going to plot negative 2 right here, negative 2, negative 7. Oh, negative 2, negative 7. I already plotted that one. Ooh, sorry, silly. Negative 4, 5. 1, 2, 3, 4, 5. This little skinny parabola must be doing the Weight Watchers or something. Okay, negative 1, negative 4, and 0, 5. And so we have this narrow parabola. Oh, I remember this one was drawn on the board. Someone was very brave to go up there and draw it. And man, it was a good drawing too. I should have taken a picture and showed you that picture right here. Okay, beautiful. I did a lovely job on it. Okay, looking at this one, sketch the graph. And I'm looking at it and I say to myself, oh, let's see. I got x squared and I got y squared. So I know it's not a parabola because you don't have both x squared and y squared when it's a parabola. So when you have x squared and you have y squared, it could be either a circle. That's if your coefficients are equal to one another. And, well, they're not. Coefficient here is 1. Coefficient there is -4. And I know if they're different signs, it's a hyperbola. If they're the same sign, but not equal to one another, it's an ellipse. And so I'm like, it's a hyperbola. And I don't know why I would be like, it's a hyperbola. Or, it's a hyperbola. Who's texting me? What do they want to say? I turned off my quacker. Oh, it's my son, Tyler. He says the Angels won. Which is awesome. 4 games in a row for the Angels. It's hard to be Angels fans because you don't get a lot of wins. Okay, so dividing by 36. And we all became Angels fans so that we'd have something in common with my dad. And his big joke is that the reason that he became an Angels fan is because they had no fans when he joined their fan group. And so here, x squared over 36 doesn't reduce, but 4 and 36, you can put it in your calculator. And in fact, I encourage it. 4 over 36, right, is 1/9. 1 over 9. So this is minus y squared minus 1y squared over 9 equals 1. Ellipses and hyperbolas, you want to have 1 on the other side. And their important features are a and b. So a squared equals 36. That means a is 6. And b squared equals 9. That means b is 3. So a is 6 and b is 3. And what that means is from the center, you're going to go to the left 6 and to the right 6. And you're going to go up 3 and down 3. And so that's what it means. And our center on our hyperbola is 0, 0, because it's just x squared. So it's 0, 0. And so to the left 6, 1, 2, 3, 4, 5, 6. To the right 6, 1, 2, 3, 4, 5, 6. Up 3, 1, 2, 3. Down 3 from the center, 1, 2, 3. Build a box. And this is called the box method of, I have to take off my glasses for the box method of hyperbola building. Should have used a color like red. I'm drawing that dotted. Can you see it going dotted? And then I'm getting something straight that I can draw a straight line with. You're like, that might not be long enough. So right through the center and right through the corner. Corner to corner. And right through the center. And right through the corner. And then those are the asymptotes. So this is an asymptote and that is an asymptote. And how did we build them? With the box. That's how we got it built. And then we know because our x is positive that we're going to be vertex on the x-axis right here. That's our vertex. And I'm going to draw in my hyperbola. I don't know if I should risk this purple pen. No, I'm not going to risk the purple pen. I'm going to do it with the red pen. So I'm going to draw my hyperbola in red. That pen was so thick that I wasn't sure how it would go. So there's my hyperbola. And you notice I've drawn it here at the vertex, and it goes out and it sort of starts to look like a straight line over here. It doesn't cross that asymptote. The asymptote just kind of holds it in. It just kind of gets closer and closer to that asymptote as we go. So there's our hyperbola. We did a lovely job on it. Number 7, I can't believe it. We're 2 away from calling this video done. And so I say to myself, what do I get myself into sometimes? So I notice x squared and I notice y squared. And that's just x, that's just y, that's a number. So what's going to tell me what it is x squared and y squared. That means it's either a circle, an ellipse, or a hyperbola, because it has both of them squared. Now, when they're on the same side of the equation like they are, if they're both positive and they have the same coefficient, circle. So coefficients 1 is positive, coefficients 1 is positive. They have the same sign. So it's a circle. So I'm saying to myself, it's a circle. Now, what a person needs to tell the world when they're trying to graph a circle is they need to tell the circle, the world, what the center is and what the radius is. And so I'm going to go find those things. I'm going to put that answer right there because I don't want to just tell people that you need to know the center. I want to tell them what the center is. And so in order to know the center, I feel like I need to have more room. And I have room here, but I think I'm going to use the room down here. And so what I need to do is I need to put the x's together, x squared plus 8x. And I need to complete the square right here so that I can factor it into a perfect square to put it in standard form for a circle. And then plus y squared, and then I have minus 2y, and then plus, and then I need to have the new c, as I call it. And then on the other side of the equation, this 15 needs to jump over there and add 15 to start to become my radius. And so you need to have your x squared and your x, and then you'll come up with this thing that makes it a perfect square. Your y squared and your y, and then you'll come up with a thing that makes it a perfect square. And then your radius, we're already building it. You have to have it on the other side. So we're trying to get this thing in standard form. And we're like, oh my gosh, we can do it. We can do it. Oh, was I wearing that? I hope I didn't lose my bracelet. Was I wearing that bracelet? I don't remember. I hope I didn't lose it. I'll be really sad if I did. But it won't be the first bracelet I've lost, so I'll just get over it. And so the new c is b divided by 2 squared equals, I sit down and I'm so cold, and then I start doing math, and it makes me so excited that I start shedding clothes here. And so now I've taken off my jacket, but that I thought I needed. And I know you're thinking, you need a jacket in May? Yeah, you need a jacket in May. The weather's crazy. And so b divided by 2 squared, 4 squared, which is 16. So I'm going to add 16 right here. And what you do to one side, you got to do the other, plus 16. You can't go around doing just something to one side. It's not fair. And then over here, the b term is negative 2. So the new c that we're going to be building here is b over 2 squared. That's the formula. Negative 2 over 2 squared. So that's negative 1 squared, which is 1. So I'm going to add 1, and I'm going to add 1. When the dust clears, I'm going to factor this, which is x plus 4 times x plus 4. No coincidence, that's x plus 4 squared. So if you're like, wow, it became that. No, 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 no. I planned for it to become that by choosing that particular value of c. So it would have factored to be just anything, right? Any old something. And I could have picked a lot of different values, but I wanted it to look like that. So that's why I picked 16. So now we've picked 1 here, and I'm going to factor that as well. And yeah, friends, that factors as y minus 1 times y minus 1, right? Which is y minus 1 quantity squared. And yeah, on purpose. That happened on purpose. And then here, 15 plus 16 plus 1. Now, this is not happening on purpose. This just is what it is. So these being lovely happened on purpose. This being non-lovely just happened because that's what it is, 32. So here, our center is -4, opposite sign, right? You guys remember that? 4. And then opposite sign, +1. That's our center of our circle. And then this is our radius squared. Remember the standard form of a circle? So our radius is the square root of 32, which is, on the calculator, not a nice value. Square root of 32 is 4 square roots of 2, which is about, and I'm only doing this for me so that I can graph it, about 5.6. Oh my gosh, am I going to be able to graph a circle tonight? I don't know. Pretty long day. 1, 2, 3, 4, up 1. There's the center. So over 5. 1, 2, 3, 4, 5, and then 0.6, right? So just a tiny bit more, a little more than halfway. Up 1, 2, 3, 4, 5, and then just a little more than halfway. Gonna run out of room going this direction, but I can count this way. 1, 2, 3, 4, 5, 6, and a little more than halfway. So I'll get my little notepad here and I'll measure out that distance. And I'll come over here and I'll just measure out that distance. And I've noticed that I draw them a little bit better if I do some other points. And so I just kind of use, because remember the distance from the center is all the same in every direction. And so I just kind of get myself, instead of 4 points, I get 8 points using a little, well, you can see that I'm just using a note card to make a little side. And you can already see this circle forming. Really helps my circle drawing, although my circle drawing is not perfect. And good news, I don't expect yours to be perfect either. If you want yours to be perfect, go to the Walmart and buy you one of those circle drawers. And then it'll be perfect. And so that's pretty good. We did a lovely job on that. Okay, number 8. Don't skip number 9, friends. Okay, number 8, what is it? It says, find the equation of the line that passes through the points -3, 1 and 2, 7. So I remember that when you're trying to find the equation of the line, you got to know what type of line is it. So I'm trying to know type. Is it vertical? Is it horizontal? Or is it slanted? Because this tells me something to do. This tells me something to do. This tells me something to do. So I'm like, what the heck is it? That's what I got to know. So ways that I can know what it is I can graph it. And then I'll know if it's vertical, horizontal, or slanted. That's one way. Another way I can know is I can find the slope. Now, why I like to find the slope is because if it turns out to be slanted, then that's the first thing that I'm going to want to know is what is the slope. And I've already started in that direction, right? So that's the reason that I probably would tell myself I got to find the slope. Now, if you're saying to yourself, well, how do you find the slope given 2 points? Well, you could plot them, and then you could count the rise and the run, or you can use the slope formula. Your choice. What's wrong, Susie? What? What's going on, girl? What's wrong? Has Mama been working? She says, stop working and pay attention to me. Math is so boring. One time she tore up. I was teaching a new class that I'd never taught before, and she tore up the book. She was so jealous. And I felt bad because that meant, there was probably cat to human neglect there. Y2 is 7. Y1 is 1. X2 is 2. X1 is -3. In the numerator, I get 6. In the denominator, I get 2, take away -3, that's 5. So I get 5. And that doesn't reduce. If it reduced, I would reduce it. But now I know it's slanted because I know that vertical lines, if you find the slope, you would find that it's undefined. If it was vertical. If you found the slope on a horizontal line, it would be 0. On a slanted line, It is anything other than these two things, right? I don't know. Not undefined. Any number, though. And not 0, right? That's what it is. So I know it's slanted. So I'm like, okay, I have a slanted line. And the equation builder for a slanted line depends on whether or not you know the y-intercept, or you can just go with the general one that does it even if you have the y-intercept. If I was to plot this point, it's not on the y-axis. If I was to plot that point, it's not on the y-axis. So I'm using the general equation builder, which is this one, y minus y1, not the special one, for when you have a special point. This was for any time that you have just a boring old point. And I can use this point or I can use that point. I've already labeled this one the ones, and there's nothing particular wrong with this point. And if you use this point, you'll get the same answer. And so if you want to do that, you can either one. It doesn't matter. Flip a coin. It doesn't matter. You can say, well, what's wrong with this one? It has a negative, and this one doesn't have any negatives. And so this one's a little bit better because of no negatives. Okay, cool. You can say this one's better because it has a 3, and obviously 3s are better than any other number. I'm just kidding. I don't know if 3s are all that good. But anyway, so that's the story there. Either point, it doesn't matter, flip a coin. I'm going to use this one just because it's labeled first, and there's nothing particular wrong with it other than a little tiny negative, which I'll get over. So y minus 1 equals the slope 6/5 times x minus, and then what is my y1? My x1 rather, -3. So when the dust clears, I'm out of room. I get y minus 1 equals, resolve the double negative, so 6/5, x plus 3. Yeah, I know. You could have resolved the double negative in your head. Go ahead. Do it. I double dog dare you. Now I have to distribute. I don't recommend doing that in your head. I recommend writing it and making sure that you do it correctly. Most people can resolve the double negative in their head. You can use your calculator if you need to multiply 6/5 times 3, but you get 18/5. Last step is to add 1. And yeah, I do recommend that you use your calculator right there. So y equals 6/5, right? Because I got to solve it for y. Equation of the line that's a slanted line looks like y equals mx plus b, right? And so I've got the m, 6/5x, and I'm finding the b right now. And how I find the b, it's positive 18/5 plus 1. So 18/5 plus 1, which is 23/5. And that's our answer. That's the equation of the line. Put that right there on my answer line. Find the equation of the vertical line. So they're telling us it's vertical. That passes through the point, -3, 1. So just like when we decided it was a slanted line and I whipped out the equation builder, I said this is going to build the equation. And all we have to know is a point and the slope, right? Well, that's what I'm going to do here for a vertical line too. It has an equation builder, but it's different for a vertical line than it is for a slanted line. So for a slanted line, my equation builder is y minus y1. I'm so aggressive, I broke my pencil lab. Times m times x minus x1, right? That's if I just know any point on it. For a vertical line, it's x equals a number, and I just got to figure out what that number is. And for a horizontal line, friends, it is y equals a number. Those are my equation builders. So I know it's vertical, so I'm like, x equals a number. I got to figure out what the number is. So I'm like, hey, point, do you know the number? And this point says x is -3. And this point says y is 1. And I'm like, but I only care about x because that's what my equation needs. So x is -3. And then I'm done. It's almost too easy. We didn't, fill the space with writing like we did on these others and have to go on to the side. And so I know how that goes. Okay, friends, that was Lab 50 of 3 to review. And so anyway, okay, so that's my story. I'm clicking off here. Stop the recording.